Is on the back side of the note packet, and we have two more properties of a rhombus. One is the diagonals of a rhombus are perpendicular. They cross at 90-degree angles, right? So this is 90 degrees right here, 90 degrees here, 90 degrees here, and 90 degrees here. And then the other thing is that the diagonals of a rhombus bisect a pair of opposite angles. So essentially, like, let me put some numbers on here. If this whole angle is 50, then if we were to bisect it, if we were to cut it into equal pieces, this would be like 25 and 25. But then this diagonal does the same stinking thing to this angle down here. So this would be also 25 and 25. So let's see. So that would mean if I look at one of these triangles, that the remaining angle in this triangle would be 180 minus 90 minus 25 would have to be 65. And to be honest, all the other angles that I have left would all be 65. Oh, it's not working. Come on. So what's kind of cool about a rhombus is you can think of it as just four right congruent triangles. This yellow one, there's four of these little guys, and they are all the same angles in all of them. So four right congruent triangles. There are in a rhombus. In a rhombus is one way to think of that. And again, I think it's a shortcut to think of it in terms of triangles instead of trying to remember all of these properties by myself. I think it's a whole lot easier to remember. There's four congruent right triangles. All right, so let's apply this in example 2. Find the measures of the numbered angles in each rhombus. Okay, so I personally like to start with the angles in the middle. You don't have to. You can do this in any order that you want. But I love that these angles in the middle are automatically 90, where those diagonals cross is 90. So we know angle 2 would be 90 degrees. Angle 3 would be 90 degrees. Some of you may be thinking about right now about, since this is a type of parallelogram, your alternate interior angles are congruent. That is, angle 1 is 59 degrees because it's a Z, because we have parallel lines because a rhombus is parallel. And then remember when we looked at these congruent triangles, those ones next to each other were the same amount, which is how we know that angle 4 is also 59. It's like the mirror image. All right, so let's look at another one. Again, I like to personally start with those middle angles always are 90. I'm going to go ahead and put 40 is 90 degrees. Those are perpendicular. And then from there, I'm thinking about this in terms of congruent triangles. So this is 68 because these two angles are the same. And 2 and 3 are also both 68. That's that diagonal is cutting all four of those angles into equal pieces. So 2 and 3 are both 68, which leaves me with angle 1. And perhaps you're thinking about that this is 90, and I've already used up 68 degrees in this yellow triangle. Oh, it's not wanting to pick up that highlighter. Come on. So 180 degrees in this yellow triangle minus the 90 minus the 68 would leave you with about 22 degrees. All right. On this last one, these darn hand-drawn pictures, Miss Benton, what I was wanting you to see is that angle 1, 2, and 3 are on the inside of this blue triangle here. They're degrees. 5, 5, and 5 square root 2 are supposed to be the side lengths of this triangle. Now this triangle is obviously not drawn to scale because look, that 5 is way shorter than that 5. But still, what I'm hoping that you're noticing is that this is a 45, 45, 90 pattern. We've seen that before where the pattern is in, and in square root 2, in which case that only happens when you have a 45, 45, 90 triangle. So 1 and 3 would both have to be 45 and angle 2 would be 90. All right, so I've got 3 you try here. I want you to pause the video and give it your best effort, and then we'll check and see how you did. You try 1 here. I hope you were thinking about this 2 and 3 would both be 54 because it was 54 at the top there, and in fact this would be 54 also. And then you have a yellow triangle that is congruent to the white triangle on the left. And so you could do what? 180 degrees minus 54 minus 54, and that would leave you with 72 degrees for angle 4. And then if that is true, then if this one's 72, then angle 1, because that's a congruent triangle, those are matchy-matchy parts, those are corresponding parts, would also be 72. You try 2, I told you I like to always start with those middle angles. We know that those are both 90, so I've already written angle 4 as 90 here. Then we know that the 15 up there at the top is going to be matchy-matchy. Those are corresponding parts with angle 3 will also be 15. And then I can use the yellow triangle, 180 degrees in that yellow triangle, minus the 90 minus the 15. Leaves me with 75 degrees for angle 1. So if that's 75, then angle 2, the angle next door, would also be 75. You can think of these as the yellow and the white triangle on the right as the mirror image of each other. In you try 3, this is another one where I was hoping you would notice the pattern. So 1, 2, 3, and 4 are all angle degrees, and then I meant for 5, 5 square root 3, and 10 to be side lengths. And I hope you noticed that pattern, that this was in square root 3, and 2 in which case this is a 30, 60, 90. We know 30 would be where 4 is, 60 would be where 2 is, and 90 would be where 3 is, in which case 1 would also be 90 because it's vertical with 3. So angle 1 is 90, 2 is 60, 3 is 90, 4 is 30, and I think that's it. All right, then in this last example, we're going to actually cross out part 3 of this and just do parts 1, 2, and 4. So on a rhombus, it looks like we have some different things here. We've got RK and ZK. All right, so starting off, I've already noticed that I have 2 parts, 2 pieces, 2 halves of a diagonal cut into equal pieces, and so I know that those are going to be equal to each other. What's interesting about this problem is it doesn't start off asking us to solve for x or y, but you do have to solve for both x and y in order to solve this problem. So I can subtract 4y, I get 1 equals 3y minus 14, add 14, so 15 equals 3y, divide by 3, and y equals 5. Let's go take a look at what we have for x. So on this one we have pk, which is this piece, and yk, which is this piece. So again, the diagonals cut each other into equal pieces, and so I know I can equal those in order to solve for x. So let's see if I can scooch this in. So I'm going to say 3x minus 1 equals 2x plus 6. Subtract 2x from both sides. So that leaves me with x minus 1 equals 6. So x equals 7. All right. So the first thing it asked me for in this problem is to find py. So I know the two blue turquoise pieces, so if I plug in x is 7 into those, I should be able to figure out the whole. So this would be 3 times 7 for x minus 1, so that's 21 minus 1 would be 20. And then we know, here let me zoom in, we know that these are the same, they're congruent, so I really don't even have to plug it into the other one. They would automatically both be the same, they'd both be 20. So py, the whole, one part's 20 and the other part's 20, the whole would be 40. Same thing with rz. They want to know the entire length of that yellow line, so we can just plug in this y is 5, so that would be 4 times 5 plus 1 would be 21. Just like before, we know the diagonals are cut into equal pieces, so they would both have to be 21. I don't even have to plug it in on zk, although I would get 21. So this comes out to 21 plus 21, which is 42. And then the last question is, how many degrees is angle y to the k to the z? Y to the k to the z is this angle here, and we know that those diagonals cross in such a way that they form 90-degree angles. They are perpendicular, so that would be 90 degrees. Your homework is going to be Math Excel, and you're going to do the rhombus assignment. And I'll see you guys next time.